Hello, everyone. Welcome to the TDWI webinar program. I'm David Lotion with Knowledge Integrity. I'm also an affiliate research director for TDWI. For today's program, we're going to talk about an expert panel, the modern data management platform, unifying the data warehouse and the data lake. Today's sponsors are Matillion, Snowflake, and Trifacta. For our event today, I'll kick things off with a short presentation. Following that, I'll host a panel discussion with Jamie Cole from Matillion, Kent Graziano from Snowflake, and Shyam Srinivasan with Trifacta. But before we get started, I'd like to cover a few basics. Today's webinar is going to be about an hour long. At the end of our discussion, we're going to host a question and answer period. And if at any time during the discussion, during the panel discussion, you'd like to submit your own question, just use the Ask a Question area on your screen to type in your question. If you have any technical difficulties during the webinar, please click on the Help area located below the slide window, and you'll receive technical assistance. Our attendees often like to discuss the webinar on Twitter with other attendees. And if you'd like to do that, include the hashtag TDWI in your tweets. Finally, if you'd like a copy of today's presentation, use the click here for a PDF line there on the left middle of your console. In addition, we're recording today's event, and we'll be emailing you a link to an archived version so you can view the presentation again later if you choose, or share it with a colleague. Again, today we're going to talk about the modern data management platform, unifying the data warehouse and the data lake. A little bit about myself. I'm the president of Knowledge Integrity, which is a consulting company that focuses on information management solutions for information quality, business intelligence, and analytics. I am well known across the information management space, and I do a lot of writing and speaking on that topic, including frequent appearances on TDWI events, webinars, and conferences. I am also an affiliate analyst with TDWI. I am the program director for the Master of Information Management program at the University of Maryland. So just a quick reminder to our audience. If you have a question, you can enter it at any time in the Ask a Question window, and we will answer audience questions in the final portion of the program. So I'm going to talk about today, I'm going to introduce our program. We're going to talk about modernization trends, the transition to a hybrid multi-cloud environment, the evolution of a unified data management platform, and some emerging data strategies and architecture. And I'm going to start this out by talking a little bit about modernization. Organizations have been looking at transitioning their data architectures and strategies and moving that to the cloud. And there's a lot of motivating factors for enterprise data modernization, specifically looking at the ability to lowered barriers for increased capacity capabilities and different types of services. So scalable, high-performance cloud-based computing resources, the economic benefits of the cloud, the ability to manage and make use of massive volumes of data, the integration of open source tools and open source capabilities, the ability to manage data streams that are coming in real time from a variety of different types of sources, broad data consumer communities that are looking to make best use of their information. And I just want to provide a quote from a recent best practices report that Fern Halper wrote. As organizations collect large amounts of diverse data, they often want to modernize their data and analytics environments to support new use cases such as building machine learning models for image recognition, analyzing Internet of Things data, and deploying conversational bots. Now, the thing about modernizations is that it's a little bit different than just talking about migration of your data and applications to the cloud. Modernization, it really is a strategic process that affords the opportunity to re-examine whether the legacy systems that exist continue to meet the business requirements, to identify and eliminate dependencies that were made based on decisions made at the time when the available technology perhaps created some barriers to be more agile, and then be able to refactor or re-engineer the enterprise to align with emerging process demands. So what modernization allows you to do is to reframe your analytics data architecture. Reporting, business intelligence, analytics platform architectures are continuing to evolve. And they started out looking like this, with a traditional data warehouse that contained an that was contained within an on-premises data center with a firewall around that, and then sets were extracted from operational or transaction systems and streamed or batch streamed into the data warehouse. Distributed computing coupled with low-cost open source tools lower the barrier to entry for implementing what we would call high-performance analytics. And so we end up with a different type of architecture, which is a data warehouse that's essentially distributable across different platforms. And now when we look at the cloud, what we end up with is an evolution of an architecture that allows data lakes, data warehouses, different types of data organizations to continue this trend of analyzing increasingly distributed data that's implemented in the cloud architecture. And so we end up with this hybrid multi-cloud environment where we've got multiple clouds, cloud instances, perhaps with the same cloud service provider, maybe with different cloud service providers, all interoperating with our on-premises data, which still remains and is probably going to remain for the near term. In fact, what we're looking at in terms of some of the research that was done recently by TDWI, 36% of the respondents in a survey, when asked which statement best describes your current data and analytics environment, said that their environment is hybrid, that it is a combination of on-premises and in the cloud. Not as many are just completely in the cloud. There are still a lot of folks who are still working for organizations that are largely, if not all, on-prem. But what seems to be the trend is people migrating towards the cloud, which means that they've got a combination of on-prem and cloud systems that all need to talk to each other, share information, et cetera. What that means is that we have to rethink what it means to have a data warehouse in the cloud. Cloud adoption has motivated a perspective on managing data in data warehouses or data marts or data lakes in a cloud framework as technical assets, and it presumes that data consumers are going to be expected to know exactly where every single data asset is and what's the status of each one of those assets and what privileges does each individual have to be able to get access to that, et cetera. We can't really be thinking about this truly distributed architecture because it's not scalable and it's not maintainable. It's not sustainable in any way, shape, or form. So we have to stop thinking about the data warehouse as one of the data islands and data lakes as one of the data islands, et cetera. Instead, we want to have an asset-oriented approach that leads to dissolution of the enterprise data perspective, and that means reconsidering fundamental ways that information is accumulated, managed, and then provisioned to the different types of data consumers. And that has led into the descriptions and unification of what's called the Unified Data Management Platform, which is a unified environment that provides tools for analytics, for the full analytics data lifecycle, support for data management, development tools, as well as sophisticated analytics. And if you look at the image here, we have a kind of a mock-up of the unified platform for modern analytics, where we've got a variety of different data origination points or artifacts that are streaming into an environment that is bound by governance and security and has a deployment infrastructure that is able to satisfy the needs of a variety of different classes of data consumers, ranging from a data explorer, data scientist, an analyst, a business user. Perhaps you have a senior manager who's looking at a populated dashboard, developers, et cetera. And this unified environment is typically going to be cloud-based. Because it is based on leveraging cloud services and cloud resources, it's going to be scalable and able to support massive data volumes. But in turn, we also want to automate as much as possible to address the data and analytics complexity. So what does that mean? Well, TDWI recently did a survey soliciting opinions about expectations for a unified platform. What I've done here is I kind of called out some of the answers that rated relatively high in terms of agreement. Unified platform should connect modern and traditional data sources. It should connect to a broad range of data sources. Automation and augmentation tools are critical. as remote work has become a norm, the unified platform should provide a place to collaborate. The unified platform should provide guided navigation to help data consumers find the right data, and a data catalog is critical. And really what this is saying is that we can boil this down to these four basic core ideas: connectivity, automation, collaboration, and data awareness. These are all key aspects to the modern unified data environment. So to summarize somewhat, data assets are increasingly distributed as organizations modernize and migrate to multi-cloud environments. Modernization presents an opportunity to devise new data strategy and new data architectures. And unified platforms and environments provide an integrated set of capabilities addressing the end-to-end data and analytics lifecycle. And with that, just a reminder, if you have a question, you can enter at any time in the Ask a Question window. We're going to be answering audience questions in the final portion of the program today. But now what I'd like to do is introduce our guests for today's panel discussion. First is Jamie Cole with Matillion. Jamie Cole is a product manager with over 7 years at Matillion, covering roles such as implementation consultant, professional service delivery, and product management. Jamie has been involved in the data space throughout his career in areas such as data migration, data warehousing, and implementation of data lake projects. Our second panelist is Kent Graziano with Snowflake. Kent Graziano, also known as the Data Warrior, is the chief technical evangelist for Snowflake and an award-winning author, speaker, and trainer. He's an Oracle ACE director, Knight of the Oak Table Network, a certified Data Vault Master and Data Vault 2.0 practitioner, and expert solution architect with over 35 years of experience, including more than 25 years designing advanced data and analytics architectures in multiple industries. And our third panelist today is Shyam Srinivasan with Trifacta. Shyam is the head of product marketing at Trifacta and brings years of industry experience, having led teams in product marketing, product management, and engineering in different technologies, including data analytics, AI and machine learning, and data center networking. Previously, Shyam was a product marketing lead for machine learning services at Amazon Web Services, focusing on Amazon SageMaker. During his tenure at AWS, Shyam was also a product management lead for teams across the AI, ML space, IoT, and network infrastructure. And prior to AWS, Shyam led both product management and engineering teams for data center networking at Cisco Systems. Shyam is passionate about data and making it useful toward a better world. Outside of work, Shyam loves to travel and being outdoors with his family. Welcome, everybody. Thank you very much for coming to our panel today and participating in this discussion. And what I'd like to do is I'd like to begin. Jamie, I think I'm going to begin with you and ask this first question. What have your customers seen as being their biggest barriers in transitioning systems to the cloud? Well, it looks like Jamie seems to have dropped off, so I'm going to actually... oh, there you go. Jamie, you still there?
Yeah, apologies. A slight connection problem there, but I'm back now.
All right, great. Welcome back.
Thank you.
So, biggest barriers in transitioning systems to the cloud?
Yeah, I've kind of disconnected at the absolute worst time there as you asked me the first question. What we hear from our customers in this particular area, the barriers in moving to the cloud from a more legacy on-prem solution, primarily it's the concept of security, really. How can they be sure when they're giving their most critical lifeblood of their company, their data of their company, to what is seen as a third-party provider, one of the cloud platforms and the services that run on top of it? So, yeah, number one, it's understanding the security model and becoming convinced that it is secure. And secondly, the mindset shift that's required. You can't just necessarily bring your on-prem applications straight into the cloud because they won't truly take advantage of the scalable nature of the cloud. So there may be a certain amount of re-engineering of not just the tools to become more horizontally scaling, but also people's way of thinking about horizontal scaling. You know, it's a bit of a mindset shift. So they're the two biggest we see at Matillion, really.
So actually, I want to drill down on that and maybe ask Shyam, maybe not just from your current role as head of product marketing at Trifacta, but also in your past lives at AWS and Cisco. Jamie, mentioned the first thing you mentioned as being one of the barriers is this question about security, and I think one of the bigger challenges seems to be this what I refer to as security anxiety, which I think a lot of the cloud service providers have been very diligent in addressing. So how have you guys addressed the question of security anxiety and being able to help customers overcome that as a barrier?
No, first of all, thank you for having me. It's a pleasure to be here, and a great question and a great start to the discussion. And as Jamie mentioned, I think security is top of mind when you talk about transitioning to the cloud. Going back to my AWS days, I would clearly talk about the security construct in terms of security off the cloud and security in the cloud. I think AWS really talks about it in a very clear and concise manner. And what I mean is that the cloud service provider is responsible for infrastructure security, where the data centers are located. It's not just about physical security, but it's also about the logical security boundaries that you would have in the network, right? But it is also up to the enterprise who's transitioning their systems into the cloud of what their applications, and that's where I call it security in the cloud, where you're responsible for how your applications are designed. Legacy applications always have a challenge in this regard, but that's where the line is drawn between security off the cloud and security in the cloud is where you need to think through this. And I would wrap it up with saying that I think it's about fear of the unknown. When I talk to customers, it's always about where is the leadership. The thought leadership has to be about, yes, it is going to be a different paradigm moving to the cloud. So that thought leadership has to be driven across the organization, and that fear of the unknown has to be overcome as you move systems to the cloud.
Thanks. Kent, maybe you can talk to the second point that Jamie raised, which is about mindset shifting and re-engineering, and how your customers have kind of come around to that whole concept.
Yeah, that is definitely one of the major hurdles. Coming from the on-prem world to the cloud world, even at a very fundamental level, the DBAs of the world have, say, set patterns of what they did for performance tuning, for adding new sources, things like that. And the cloud's just different. The tools are different. If you're dealing with Snowflake, we don't have indexes. And that, as simple as it seems, has been a major shift for many of the technologists that I've worked with. Is like, what do you mean there's no indexes? How do we tune? Well, you don't, because we're scaling compute. We've built an efficient processing engine for you. It is delivered as a service. And so this idea of we had to manually do everything ourselves to make this really work, to all these things are services now. And it's the vendor's job to make sure it works well. That's been a huge change in thinking for many, many people, and understanding that the possibilities of something that was engineered specifically for the cloud just go so far beyond what we were able to do on-prem. And so, to your point earlier about re-engineering and really, I don't even say reframing, but reimagining what you can do in the cloud from what you could do on-prem. And getting over that hurdle is really important, because otherwise you're not thinking about it from the right perspective of how can you take advantage of the services that are now available in the cloud, because you're more worried about the nuts and bolts. It's like we've taken that out of the equation now. You can use great tools like Matillion and Trifacta and Snowflake, and so much of the manual work is gone. And now we can really focus on delivering business value, and we have to shift our mindset set to that. How can we deliver more value from the data to the business rather than how do we just onboard and optimize a bunch of SQL queries?
So it's interesting because a recent conversation I had also kind of centered on this whole question about folks being hesitant to migrate to the cloud because they don't really understand how the cloud works. And since they don't really understand that, and the learning curve for a number of people is somewhat steep, and they don't really understand the difference between a system that was implemented on premises and then is lifted and shifted to almost an identical replica footprint on a cloud-based configuration versus a product or service that was built for the cloud. And so one of the kind of core questions that boils down to is that we think about these artifact architectural structures like a data warehouse or a data lake or a data mart, and how that was considered in terms of benefiting organizations to support their business intelligence and analytics and reporting activities. But on the cloud, data warehouse, data lake, data mart, do these concepts even apply anymore? And Kent, I'll go back to you on that because I think you're probably one of the folks that's thought about that pretty deeply recently.
Yeah, and I've been at it. I met Bill Inman back in the mid '90s, and so I've been at data warehousing since the mid '90s. And I think part of what we need to do is not get hung up on the terminology as much, but actually go back to the basic principles of what problems were we trying to solve with data warehouse methodologies and data lake approaches, and look at it from that perspective. Because to a certain extent, part of I think the challenge in the mind shift change is the fact that we've been thinking in terms of a data warehouse, and this is what a data warehouse should look like, and this is what a data warehouse should do. And so, okay, that answers questions from what you were doing over the last couple of decades, but how do we solve the problems of today, especially with streaming data? It's very different than when I did data warehousing in 1995. It was load data from a COBOL system once a month and run some aggregations, to what we're doing today of trying to stream near real-time data in and IoT data, as you mentioned, and do machine learning. That there's a certain amount of constraint by continuing to think in terms of data warehousing and data lakes. Now, yeah, you can get data warehouse functionality and data lake functionality in the cloud and in services like Snowflake and Matillion. We serve those, but there's just so much more that we can do that I'm afraid people are constraining their vision of what they could do with, as you call it, a unified data management platform. That's a much more broad, open perspective to think about what could we do. What value can we bring if we break out of the mold of the traditional data warehouse and traditional data lake concepts?
So it sounds, if I can kind of reflect back on what you're saying, it's that we as data management professionals may have kind of obsessed about structure when the world is moving towards thinking about content, and that
yes,
if we transition to thinking about services instead of structure and satisfying needs, then we won't be bound by structure. Is that?
Yeah, exactly. And it actually kind of morphs over into the whole data mesh conversation that's going on in the industry now, is thinking of data as a product. And it's about data providers and data consumers. And if using dimensional models is the best way to deliver the data to your consumers, well, great. That's a useful concept and it's a useful tool. But let's not be constrained and think, well, everything has to be a star schema. Everything has to be third normal form. Everything has to be data vault, whatever it is. That it's really about what's the best way, most efficient way of delivering the data as a product to the folks who can benefit from it.
So, Jamie, let me turn to you and kind of solicit your thoughts about that in terms of making data available. Again, the core question was data warehouse or data lake, and does that really mean anything anymore? But from your perspective and your clients' experiences, what does it really mean to be able to provide a data architecture?
Yeah, so echoing a lot of what Kent said there, I come from a data engineering background, and I still sometimes think of them as separate things, the data lake and the data warehouse. But I know that's a mindset I need to get out of, because tools like, data platforms like Snowflake and tools that work with them like Matillion are blurring that distinction these days. Matillion can join data that's stored in a data lake to data that's stored in a more traditional data warehouse in a single job to help solve those problems for the people who are consuming that data. So I think, with my product background now, thinking about it in terms of problem to solve and what are we actually trying to do, we're trying to get people in the business to derive meaning from data. That's the way to look at it, and sort of going, well, you can't get that data because it's in the data lake, and right now we're looking at the data warehouse. That just doesn't fly anymore. So yeah, the concepts are blurring, and I think that's the right thing, because you speak to a lot of people who are consuming this data, they're not really caring where it's coming from a technical point of view, as long as it's giving them the insights they want. And they want the tools that they use, like Matillion ETL, to be able to access, combine, and provide insights from the data from wherever it lives. So, yeah.
Shyam, any additional thoughts? And the reason I'm actually using that as a way of prefacing the next question that I'm going to ask. So, just again, from your perspective, do the concepts of data warehouse and data lake apply when you're talking about a cloud-based modernized architecture?
No, I don't think those concepts exist anymore. They're terms. I think it's more about the function. As both Jamie and Ken mentioned, the lines are blurring. It's about I would think about it as a modern data stack, where is about the function going from data ingestion to data storage and transformation, and getting to the visualization and the insights that you need. So the data warehouse, the data lake, the data mart have become concepts, but it's more about the function of what you want to do with the data and how would you make it consumable by downstream applications.
So in the context of what you just said, as somebody, my perspective is, I think about it from 20 years of working on how to flow data from one collection of sources into the data environment or the analytics environment, and that's kind of well established as an architectural pattern. But what you guys seem to be saying is that that doesn't really hold true anymore. So yet the capabilities and the services of I would say of all the products that each one of your companies provides still has to do some kind of provision of information. So just maybe for clarification, what would you say is the difference between data integration or a data integration process or an ETL process and a data pipeline or a collection of data pipelines?
I presume it's for me. So I'll
take yes,
it. Yeah. So I think it's about, I would term it as finding a means to the end when we talk about data integration, data pipelines, right? Let's talk about data pipelines. What it simply means is a series of steps or a series of actions that you would take to retrieve data from disparate sources. Sources are anywhere and everywhere these days, heterogeneous and types of data. Load the data onto a destination, whether it's a warehouse, a mart, or a lake, and then transform the data where Trifacta comes in to make it relevant, usable. And it is also talked about, from ETL to ELT paradigms, right? So in other words, I would say data pipelines enable you to transform the raw data from sources, and make it available for analysis. Now, when you talk about data integration, it's about combining the data to provide a unified view. So if you talk about the two, the data integration is part of the data pipeline that you use for eventual analysis and getting the insights, right? Now, a lot of people talk about integration as the entire process of cleansing and transformation. I think it's about mixing up the two. I truly believe integration is part of the data pipeline. That goes into data ingestion, data transformation, and enriching the data for analytics and machine learning.
So, Jamie, I'll turn back to you because you actually used the term ETL a couple minutes ago. But again, from what you guys have been saying, it's less of thinking about a lockstep process that everybody thinks of in ETL, and really kind of changing this perspective into the provision of an integration process, kind of the way Shyam was just saying, and the utility of a conceptual procedure that would be encapsulated in a pipeline. So how do you guys kind of differentiate between those concepts?
Yeah, so we do differentiate more, saying that the data pipeline is around the E and the L. It's about getting data out of those disparate sources, be they APIs, on-premise legacy databases, SaaS systems, sensors from IoT devices. It's about getting the data from those disparate sources into a common data platform, be that Snowflake or something else. Whereas the data integration process is then about really adding meaning to that data by combining it with other data sets. So we do see a separation at Matillion between the pure data pipeline of ingestion, which may do some basic transformation or some basic data cleansing on the way in, but really you're then landing that data in a fairly raw form before using it as part of a data integration process. And kind of the point of that is you might not know all the uses that you want to get from that data at the point that you're ingesting it. Certainly sensor data, for example, if it's landing that quickly, you don't necessarily need to process it instantly. And then when you do process it, you may only take general trends from those sensors as part of your data integration. Your data integration process. But you want to land that data in its raw form so you can go back in the future and maybe look at parts of that data that you didn't know you needed at the time that you built the data pipeline. So while Matillion ETL will do the E and the L and the transform, kind of a best practice of ours is like store as much as you can and then run a data integration process to shrink that down and get the insights that you want from it and store those separately. So yes, very much related, but to Matillion, separate concepts.
So I think I might want to drill down on that a little bit and then get your answer, then kind of get Kent's perspective on this next question. One of the things that we were talking about earlier is that it's not just moving to a cloud, but it may be moving to multiple instances running within the domain of a single cloud service provider or perhaps even multiple cloud service providers. And so in this really truly hybrid multi-cloud environment, you might be leveraging data assets whose physical organization or physical locations are going to cross, either different storage paradigms or even live across multiple cloud service providers. And how has this changed the traditional approach to ETL, ELT, data integration, and how can organizations adapt to this physically distributed data architecture?
Yeah, that's a great question. Looking at it from a Matillion point of view, we should always say you should be running the compute that you need as close to the data and where it is as possible. When you've got data distributed around different cloud platforms, different cloud providers, and maybe even within those cloud providers, different geographies, different AZs, you want to minimize the moving of that data because moving data across the network is time consuming. And also in certain circumstances, there may be requirements for you not to do that, be they regulatory about not moving data out of certain geographies or just internal within your organization. So we'd always say you want to leverage the compute as close to those resources as possible. Yeah, so you want to utilize the computers as close to that data as possible to minimize the moving and make sure you're processing that data both in a way that meets the regulations that your company has or maybe are imposed on you by the regulators, and to make sure it happens as quickly as possible. And that's a bit of a paradigm shift from the more traditional ETL processes, which was always take the data out, suck it into the memory of whatever is doing your data processing, process it and write it back out again. It's too slow, and in certain circumstances, you just can't do it.
So, Kent, I think you guys are going to have a similar, but perhaps maybe orthogonal perspective on that same kind of question about being able to manage data and manage integration across a physically distributed data architecture, even if that physical distribution is still considered a logical or virtually unified as a single set of data assets. So thoughts?
Yeah, well, like Jamie said, Snowflake's definitely in line with the whole ELT approach and building your data pipelines and processing the data, using the compute as close to the data as possible for efficiency. With the multi-cloud and multi-region question of having that distributed the data distributed, yes, where Snowflake has built in our data sharing capabilities to try to enable that so that it's not so he's not having to build complex ETL processes to replicate data from one point to another and move it around and potentially lose track of it. And so we've definitely seen that within our customer base. Actually following the pattern Jamie described quite well there of onboarding the raw data as much as possible into their Snowflake account, and then doing the transformations within Snowflake of, I'll say, a curated data set, for lack of a better term, and doing that, and then potentially, sharing it out from there to other Snowflake accounts or other parts of the organization in a simple manner using our data sharing capabilities. But it's definitely presented some new challenges where governance starts to come in. Because of localization of privacy and other regulatory concerns. Some data can't move out of a particular country, which means that data has to stay there. And if somebody needs to access that data, well, then they have to, I'll say, connect to it remotely, run their queries in place over there. And again, still bringing the compute closer to the data. So we're seeing a lot of variations on that. That's sort of growing as our whole concept of the data cloud is growing, of this network of all this data in all these different places, but still being able to share it as appropriate, as we talked about with data as a product, sharing it with other parts of your organization or even potentially other partner companies within the confines of a unified data platform that is highly governed. So people are only seeing what they're allowed to see, and the data is only moving if it's allowed to be moved, and in most cases not moving. That's why we really we have that separation of compute from storage in Snowflake, so that we store the data once, but you can access it with multiple compute nodes. And again, one of the benefits of the cloud. So we see all of this playing out in our customer base, and it is part of the mind shift, right? It's not export the data from a database to a set of flat files and put it on a secure FTP site and then have somebody else pick it up and ETL it into another platform in another geography. It's all being done seamlessly behind the scenes in a platform as a service. And Matillion's service is one of the ones that people use on Snowflake to help move that around and then take advantage of features for data engineering that are built into the platform around streams and tasks and all stored procedures and all that sort of thing to really, again, keep the processing as close to the data as possible for efficiency.
So I am detecting a little bit of a theme there with respect to the question of governance. There's just one other aspect of data preparation that I want to ask Shyam about, which is why is data preparation different in a hybrid cloud environment than what people are used to in their on-prem data center configurations?
Sure. So before we talk about hybrid cloud, let's talk about data preparation as a principle, right? So no matter where the data is stored, organizations need to be able to prepare it to make it consumable. I would like to quote a quote from DJ Patil, who was the first chief data officer in 2012 of the United States. He said that 80% of the time is spent in data projects for data preparation. Unfortunately, 9 years later, it's still true. Right. So data preparation is challenging, but it becomes even more challenging in an environment like a hybrid cloud, as you mentioned. In such scenarios, data is siloed, making it difficult for business users and data practitioners, to transform the data, and obviously creating a nightmare for data governance. So how do you actually, overcome these hurdles, right? At a high level, I think you need to leverage shared logic across the data sources. Right now, this not only enables data preparation, but also advocates better data governance. Let's peel the layers a little bit, what I mean by that, right? I think one of the critical points is about common metadata. When you talk about metadata, it's a data that you care about, right? Wikipedia talks about it's a data about the data, but I think it's the data that you really care about. Which needs to be consistent across environments, whether it's on-premises, the cloud, or in a hybrid cloud environment, right? When data is spread across such diverse environments, differing metadata can cause confusion. And, that's where an interoperable application like Trifacta allows for a common framework to manage this diverse metadata across environments. The second point I would like to make is about a uniform preparation logic or data wrangling logic. Now, irrespective of the language you choose, you could you pick your favorite language, right? SQL, Python, or even Excel macros for that matter. If you can have a single data preparation logic, which can be shared, reused, and scaled, then you accelerate the end-to-end data preparation across the entire environment and get your required insights. And the last, but certainly not the least, is about a common user experience. Right now, freeing data practitioners, whether you're talking about a data engineer, an analyst, or a scientist, for a heterogeneous data environment, and empowering them with a consistent user interface across the environment leads to remarkably faster process in preparation and driving analytics. Now, we strongly believe in Trifacta of providing that user experience where data preparation should enable data democracy. When I talk about democratization of data, it's about access to data with the required security constructs across teams without having bureaucratic boundaries, and where everyone can explore the data, prepare the data, and teams are empowered to collaborate more effectively to profile the data, prepare the data, and eventually pipeline the data, accelerating transformative insights into the business.
Thanks. So you also, all three of you have mentioned governance, which I'm almost tempted to say is one of the elephants that's in the room, and I think it's worthwhile for us to call it out and talk about governance, especially in the context of the concern that organizations have about it. In fact, I was just reading through some recent TDWI survey responses that said that almost half of the respondents had said that data governance in cross-cloud environments was one of the top challenges of moving to the modernizing on the cloud. How do you govern and secure the diverse types of data, multiple use cases, multiple location sovereignties, laws, et cetera, in a unified multi-cloud environment? And I think, Jamie, I'm gonna ask for you to start this one off.
Yeah, we've all seen the problems that can occur if there isn't proper governance in place, especially as more and more data is ending up in a cloud platform and potentially more cloud platforms. I'm thinking, the concepts of data swamps, where you've got S3 buckets full of data, full of files, full of semi-structured data. No one really knows what's in there. No one really owns it. And the first solution that tried to solve this are the concepts of the data catalogs, sort of lists that are available to who's in the business. Lists of what data is available and who within the business can access it, which went some of the way to solving it. But it doesn't really solve the data swamp problem or the data ownership problem. Some of the data cataloging tools try and force you to assign a data governor to the data, so at least it's owned by someone. But I think the trend that's really going to sort this problem out, and what we're seeing more and more of with our customers at Matillion, is the concept of a data mesh, which has come up on more than one occasion today. And the basic tenets of that sort of methodology speaks to me as a product manager, in that you want to assign owners to the data who own the data, not just the files that exist in S3 or the tables you've got in your Snowflake database, for example. They own it from, like a product owner owns features within a product. They're responsible for the changes to that data. They're responsible for publishing that data, and they're responsible for governing who has access to that data. So I think this, the data mesh is really the solution to this. And each data set has an owner who is responsible for it, knows where it is, and knows the rules that apply to that data, regulatory, who can access it within the business, and making sure it's interoperable with the other data sets that other people within the organization are owning.
Sean, let me turn to you. Thoughts about the question of governance in a multi-cloud environment?
So I think governance, irrespective of the environment, is critical, right? I think it's the multi-cloud environment, maybe governance becomes more interesting, right? Where you got to. I think it's acceptance of the fact that the environments are going to be difficult. You're going to acknowledge the fact that data engineering and software development are rapidly changing processes and procedures, and iteration is critical. So when you talk about governance, I think you also have to prepare for failure. In addition to what Jamie mentioned, you have to ensure that applications, architectures, and approaches will be different. You've got to follow the governance of not only your own boundaries, but the boundaries of the diverse environment. Designing for failures, troubleshooting, and evolving your thinking, I think, will go a long way as you think about governance overall, as you go from data ingestion all the way to transformative data transformation and analytics.
Kent, any final thoughts on the question of data governance? You brought it up a lot.
Yeah, no, and I'm on board with Jamie's thoughts about data mesh and the whole domain product teams concept that's in data mesh. This is not a technical problem. And as you know, David, it's never been a technical problem. We can build tools to do all this, but it's more in the data mesh world, they talk about socio-technical frameworks. It's a cultural issue within the organization, and assigning that ownership and assigning that responsibility, and people taking responsibility for the data and saying, this is how it needs to be controlled, and we're going to set the rules on it. We can give them all the data catalogs, all the data governance type rules built into the platform so that they can apply things like dynamic data masking and row access policies. But somebody has to take that responsibility so that we don't end up with data swamps, right? That we do end up with well-governed, curated data sets, the data as a product that's useful to other folks in the organization without violating privacy and security regulations.
Thanks. We've got a bunch of really good audience questions, but of course, if you still have questions, please enter them through the Q&A tab in your panel. But I'm gonna start going to some of these questions, and I'm gonna jump to one that came in a little bit relatively earlier in the discussion. Does a unified data platform have to be persisted, or can the unified data platform be virtualized for the enterprise? Isn't it more efficient to virtualize instead of persisting the data? And I think there's two spins that I think I'm going to hear on this. one which is purely talking about the technical one, and then again the other elephant that's trying to edge out the data governance elephant is the question of data mesh, and I'm just curious whether that kind of folds into this answer as well. So Kent, I'll push this one to you because I think you might have the strongest opinion about it.
Well, the first part of it is depends on what you mean by efficient, right? I think virtualization technologies are great for getting folks started. If you're talking about virtualizing across your source systems, I think over the last 15, 20 years, we've seen that doesn't scale well. It might be good for getting access to the data initially and providing an easy view, a consumable view for folks in the organization to see and work with the data. But when you start having to push that processing is going back to trying to pull data across 5 source systems at the same time and combine them in real time for integration, eventually that falls over on itself. And what I see in Snowflake is people may use that as a stepping stone to building their unified platform. And so the answer for me, of course, is while it may be more efficient to start with virtualization, long term it's more beneficial, inefficient even from a compute processing resources to persist it, because we're talking about analytics here. In this case, we're talking about analytics and the things we need to do with analytics and everything that all three of us have been saying about doing data prep, doing integration, whether it's looking at the raw data or doing highly curated governed data. It's way easier and more cost effective to do that from a persisted data set in a single unified platform. So we've eliminated the silos. Virtualization is helping you virtually pull together the silos. But there's still a lot of work there to make that happen. And long term, it's just, in my experience, it's just not totally scalable. But it is a good way to transition as you bring new data sets in. It might be the way, and I've seen customers do that. They may be using a virtualization layer to get to some of the data that they haven't moved into the platform yet. So it's part of the re-engineering effort. But in the end, then they have a common semantic layer that works against all of the data, but is way more efficient once it's all in the single platform.
So Shyam, I'm interested in your perspective. You gave a pretty good description of data preparation and how it goes above the architectural physical structure of the data. So I'm curious as to how you would react to this question about whether the unified data platform has to be persistent or is it better to use virtualization?
I think I'll echo what Ken said. I think virtualization is a good starting point, right? I think it's a good starting point as you transition between multiple environments and trying to work your data sets. But as you scale, as you scale the environment, as you bring in more data types, more data sources, and more data sets, I think you need to have that unified view. And again, going back to my point about the modern data stack of having a unified data environment, right from ingestion to transformation to visualization, I think it's critical to have that persistency of data consistency. And it goes back to the earlier discussion about the easiness of data governance. I think it's going to get more challenging as you continue with multiple environments. And data virtualization for me is a great concept as a starting point, but the more important point is about persisting the data in a unified environment.
Thanks, guys. I'm going to move to another question, and I'm going to start with Jamie. When moving to a unified data platform in the cloud, what advice can you guys provide regarding the performance challenges of moving large volumes of on-premises data into the cloud platform?
So the slowest part of most data ingestion processes is moving things over the network, especially where you're leaving an on-prem to move into the cloud. So the first thing I'd say, and I'm being quite technical here, if you can compress the data, whether you do that at the data stream level as it's flowing, or whether you can maybe move things into your database tables into files, compress them, and then move the compressed data into the cloud provider. If you can do that, I know Snowflake, for example, can load data without uncompressing the files. They can load those compressed files as they are. And that's actually a lot quicker than not just moving them because they're compressed, but also the ingestion by Snowflake is quicker. It can ingest compressed files. So yeah, it's really sort of reduced that network latency as much as you can by using compression or moving the data closer to the cloud that you want to put it in. I think that's the best answer I can give there.
Let's see if we can go through some of these other questions. Let's see. There was a good question here about the data governance and data mesh. I think data mesh solves the governance issue in the data analytics platform, but what about the quality of data at source system and collection levels? Is this not fully a process culture issue? And are there any tips for addressing that? So, Jamie, I'll push this one to you, and then let's ask Shyam his opinion about this one as well.
So I think like the ideal view of a data mesh is that every data set within your organization should have an owner who is responsible for the quality of that data. And I'd say that goes as far back as the operational source systems that you're maybe extracting data from and putting it into the cloud. So it becomes a governance issue and just making sure that a named person or a named team is responsible for the data sets that are stored within each part of your data architecture, including the source systems, really. So it is a process and it is a cultural issue, and it's about making someone responsible for the quality of that data so they can be held to account for it.
Shyam, what are your thoughts on that?
So I think when you talk about data mesh, I think it's about organizational changes, right? You want to enable your domain teams to own the delivery of the data product, right? I think when the coin was first termed, if I remember right, it's defined as a type of data platform architecture that embraces data in the enterprise, to leverage a self-serve design, right? What I think about data mesh is about enabling data consumers to discover, understand, trust, and use the data so that they can drive the related, oft-used term of data-driven decisions and initiatives. Now, when as engineering teams moved to different architectures, data mesh is seen as an opportunity to transition from things like monolithic data to microservices and the concept of breaking apart the ownership of the data around domains, which can still exist, right? So for me, it advocates distributed ownership, domain-based ownership, and building data products that are self-service and easily managed.
Thanks. I've been scanning. We've got a lot of really great questions. I don't think we're going to be able to get through all of them, but I just came across another one that I thought would be valuable to address. This one, Kent, let's start with you. How are customers adapting to the constant changes of technologies coming up in the cloud platforms?
They're having to establish centers of excellence that are keeping track of these things and figuring out how to quickly bring other members of their organization up to speed. I even see that inside of Snowflake as we adopt even our own technology, that we have people that they're focused on that, on trying out the new features, investigating them and figuring out what's the best way to use them, and then providing internal training to other team members to show them how to do it. And it's a constant learning environment, and that's, I think, everyone in our industry, that's where we need to be. And that's why we're doing things like this panel discussion, right? Is things are changing and evolving so quickly, and the opportunities to take advantage of the new technology is there, but you do have to keep up with it And having something like a center of excellence is one of the key ways that organizations have found to be able to do that.
Jamie, I'm kind of curious your perspective, especially maybe if you can adopt the customer perspective from what your experience has been in terms of adapting to constant changes of technologies.
I think what we found at Matillion, certainly with customers keeping up with the new technologies that we're adding to our products, is it's important to have a strong community for your products. So, Matillion does a lot making sure everyone's aware of the new features of Matillion, especially when they work with, say, the new features of Snowflake. Matillion's aligned very closely with the features of Snowflake. We want to integrate those with the Matillion product. And the way we do that is to stay close to the Snowflake community to know what's coming. And Matillion, we have our own community for our customers to keep up to date with the new features being added to Matillion, but also to spark discussions around trends that are being seen in the data market that Matillion need to be aware of. So the Centers of Excellence from Kent was a great idea. It is a great answer, but from Matillion, we listen to our users and we listen to our customers, and we try and stay in touch with that community to see the trends that they're interested in and read the discussions that they want to have within the Matillion community. So, for us, it's about listening to our customers and getting involved in the same conversations they're getting involved in, so we can stay up to date with what's important to people.
Thanks, Shyam. I think we're gonna let you have some opportunity to share your thoughts on that same question about the rapid acceleration of technology change on the cloud and how customers can deal with that. Any last thoughts?
I think echoing both Kent and Jamie, I think one is about customers. Certainly listening to our customers has been our bread and butter for us at Trifacta. But I think what I would add to that is to leverage the collective intelligence. You have to get out of the comfort zone of where you have been through the years. You have to leverage the collective intelligence of the industry and expertise and redefine yourselves. At Trifacta, we have done that, going from a pure data prep tool to data engineering in the cloud. So you got to get out of your comfort zone, leverage the collective wisdom and intelligence of the customers, of your partners, of the ecosystem, and then keep up with the rapid changes that are occurring in the industry.
Well, it looks like we've come to the end of our time. So let me take a moment to thank our panel speakers today. Thank you. We heard from Jamie Cole from Matillion, Kent Graziano from Snowflake, and Shyam Srinivasan from Trifacta. Again, thank you, Matillion, Snowflake, and Trifacta for sponsoring today's webinar. Please remember that we recorded today's webinar. We will be emailing you a link to an archived version of the presentation. Feel free to share that with your colleagues. And don't forget, if you'd like a copy of today's presentation, use the click here for a PDF line. Finally, I want to remind you that TDWI offers a wealth of information, including the latest research, reports, and webinars about business intelligence, data warehousing, and a host of related topics. So I encourage you to tap into that expertise at tdwi.org. From all of us here today, let me say thank you very much for attending. This concludes today's event.